Our next question is, if the monochromatic source in Young's double slit experiment is replaced by white light, then interference patterns will disappear. First one. Second one, there will be a central dark fringe surrounded by a few colored fringes. There will be a central bright white fringe surrounded by a few colored fringes. All bright fringes will be of equal width. So here, generally when you are learning textbook concept for the Young's double slit experiment, we used to say monochromatic light. That means only one colored light or one wavelength light that we are going to send through the two slits of the experiment. So there you will get a central bright fringe, and later on the diminishing of the light will be happening, but the fringe width will be same. So I will show you a picture to you. So with that you can easily assess this concept. So here in the first one we used green light, that means monochromatic light. So because of that you got a central one, and remaining fringes also there which are having same width but little bit diminishing when you are going outwards. But when you use white light, so center one is a bright one which is white also, and later on when you are going, the fringe width is same but the brightness is going to be diminished. You are having colored ones at the both ends, but at the center you will have a white one. Now come to the statements. Interference pattern will disappear. No, not at all. So this is false. And next one, there will be a central dark fringe surrounded by a few colored images. So it is saying dark fringes, so this is not the true one. This is not the right one, that means this is also false. And next, there will be a central bright white fringe, that's what we observed, surrounded by a few colored fringes. Yeah, this is true. Next, all bright fringes will be of equal width. So you observed that central one is a brighter one, and later on when you are moving away from the central one, so it is going to be like the strength is going to be diminished. So all are not exactly bright fringes. So equal width okay, but not the bright fringes. So after seeing the picture and after discussing these statements, so we got the answer that third one is the right answer. Truly theoretical. Even if you didn't observe that picture when you are learning, you can answer this one with the general knowledge only. So anyway you are sending through the slits, you are sending light, right? So the difference between those two slits will be very less because of the experiment's physical structure. So here, because of this small length only, you are getting fringes. So at the center you will get a brighter one, and later on it will be diminished. So interference pattern will be disappear. It's not at all a true statement. And next one, there will be a central dark fringe. So in double slit experiment you will get a central bright fringe, not the dark fringe. So third one. And you are surrounded by few colored fringes. Why? Because that beta is depends upon lambda capital D by D, where D is the distance between the slit to the screen and the small d is the distance between two slits. So here it depends upon the wavelength. So different colors will have different wavelengths. So you will get the colored ones when you are going away from the center, but at the center you will have a bright one. So it is true, all bright fringes will be equal width. So not at all. If you see the patterns in monochromatic light or even in colored light, white light, so you will have a central bright fringe and later on it will be diminished. The brightness will be diminished. So with the general expression that we got from the concept, and even after observing the picture also we got to know that, so there will be a central bright fringe that is white and surrounded by a few colored fringes.